I'll introduce yourself, Vincent. Okay, thank you to everyone for joining us. We're just going to give another few minutes as we let the rest of our attendees filter in from the waiting room. If you could just bear with us, thank you. Okay, hello and welcome everyone. Thank you for joining us for today's webinar. My name is Laura Egan O'Brien and I'm the Marketing Manager for the College of Engineering and Architecture here in UCD. I'm going to be your host for today's session, and whether you're joining us from near or far, we hope that you have a good time with us in the webinar, that you find it engaging and informative, and we have a chance to get your questions answered as well. This webinar is all about study opportunities and kind of the future careers from our School of Mechanical and Materials Engineering. I'll be joined by our head of school, some of our academic program directors, who'll give an overview of their various programs, and one of our current students to share her experience so far. Just a quick reminder before we get started, if you do have questions, please type them in to the Q&A button at the bottom of your screen. We'll get through as many as we can in the time that we have on the session today, but we leave them towards the end of the presentations to actually get through them as many as we can. Also keep an eye on the chat today. My colleague Katie O'Neill is joining us also, and she'll pop any relevant links that are mentioned throughout the webinar to make sure to grab them as they pop up. And then lastly, just to let you know that the session is being recorded today. So if you need to leave early, or if you miss anything, or if you know of anyone who couldn't attend or didn't register for the webinar, that link will be sent to everyone who registered later today. And also then it will be shared on our college YouTube channel early next week. So that's all from me. So without further ado, we'll get started with the session as planned. So I'm going to hand you over now to Dr. Vincent Hartigan, who's head of school for our Mechanical and Materials Engineering School.
Thanks, Laura. Hi, everybody. Delighted to welcome you to this webinar today and give you an overview of the School of Mechanical and Materials Engineering here at University College Dublin. And after me, you'll hear from a number of my colleagues who will share with you the exciting master's programs that we run here in the school. I think this slide really captures the breadth of the activities that we carry out in the school, from mechanical engineering design and modelling to biomedical engineering, energy engineering. We've got exciting activities in space engineering, robotics, intelligent manufacturing, additive manufacturing. So, as you'll hear later on from my different colleagues, we really have a wide range of programs that allow you to specialize in a particular aspect of mechanical and materials engineering. So I'm just going to share some of the key facts and headlines about our school. We're the largest school in UCD College of Engineering and Architecture. We're the largest mechanical engineering school in Ireland. We have about 40% of all the taught students in engineering and architecture in UCD. So that's about 700 students in total. And we're a pretty big school in terms of staff. By the end of this year, we'll have 40 faculty. And then overall, we've over 100 staff between research staff, technical support staff, administrative staff. We've also been very successful in our research activities over the last number of years. And I know you're interested in our teaching programs, but our success in research has really helped us to design state-of-the-art and cutting-edge teaching programs. So our research informs our teaching. So we've won through our colleagues over 30 million euros in research funding over the last 5 years. And part of that funding is our school is home to some prestigious research labs. So we're home to the Science Foundation Ireland, or Research Ireland as it's now known, IFORM, National Centre for Advanced Manufacturing. So they focus on things like metal 3D printing, materials modelling, and production systems analysis, digitization of production systems. We're also home to the Micro Nano Manufacturing Technology Centre, MNMT, which does research into machining and subatomic level machining processes. And I mentioned earlier on that we've got some exciting work in space engineering. So our school collaborated with the School of Physics here in UCD, and we designed and built Ireland's first satellite, which was launched into space in December 2023. And it's a really great example of the multidisciplinary activity that is happening in the school, not just from the mechanical engineering and the dynamics of a satellite, but also to the material science and engineering, where we've got a number of test materials on AirSat-1. So our teaching and our research themes in the school are built around four major areas, and you're going to hear from a number of colleagues about the master's programs that we offer in some of these areas. So we do a lot of work in advanced manufacturing, and that iForm Centre for Advanced Manufacturing is kind of our flagship activity there. You'll hear from one of my colleagues on our energy systems programs, particularly around the area of renewable energies. We've got a lot of activity in the area of material science and engineering. And also we collaborate closely with the School of Electrical and Electronic Engineering, the School of Medicine, School of Veterinary Science in our biomedical engineering programs. So I'm going to hand over to my colleagues now, who will go through each of those programs in more detail, and they will be happy to answer your questions as we progress through the webinar.
Great, thank you so much, Vincent. Our first program director up we have is Dr. Kevin Roach, who is the program director for our ME in Engineering with Business.
Thanks, Laura, and hello, everyone. I'm going to share some slides, just a couple of slides now as well. So the philosophy behind the ME Engineering with Business is essentially that whatever specific field of engineering you work in, your role and your skills are going to constantly develop and evolve throughout your career, and your job is going to evolve. You know, some of the jobs that you go on to do don't even exist yet. That's the first part. And then secondly, no matter, again, whatever field of engineering you go into or you specialize in, understanding the business context in which you operate is going to be really helpful. It's going to make you better as an engineer, and having that understanding along with your engineering skills is going to be good if you see yourself going down a more management focused role as well. So this program is designed to mix or blend engineering skills and business skills. So it makes you adaptable, and it helps you to understand the context in which you're operating. It's also fully accredited by Engineers Ireland. So with experience, then later you can become a chartered engineer. And I suppose one of the good things about it is that it meets a range, or meets the needs of employers across a range of disciplines, while being a little less specialized in any one specific discipline. So just to talk you through the structure of the course briefly then, the way we achieve this then is that you have essentially two parts to the program. You have your continuing discipline-specific engineering subjects, which make up 30 credits out of the total 120. And then you have management and business-focused subjects, which make up 50 credits. And then the final part, which is common across most of our MEs, is a work placement and a research project. And together in this program, they make up 40 credits out of the 120. So I guess the two main things to point out here are that within the technical specific modules, you have a mix, or you have options from civil, electrical, electronic, and mechanical engineering. So by combining those few streams together in the one module, it kind of creates an environment where you're working with people from different disciplines, which is good in terms of understanding the different specialities a little bit. It also means, depending on your own specific background and education to date, you can select modules and select a stream that suits you best to combine with the management modules. And then on the other side, the 50 business credits are shown here, or outlined here. So you have things like entrepreneurship, operations management, business information systems, and then some choices between specialities like supply chain management or project management or data analytics for engineers. So they all together, those business modules give you a good broad base of management and business skills. And you're not completely losing your further technical development as well. So if you see yourself potentially going into a management role or wanting to move towards a management role, this can help to accelerate that. And it gives you options in terms of the range of roles you can take on. And I suppose basically the maybe what you're giving up then is some of your technical specialization. Okay, so that's the main overview from me. I suppose I'll pass it back to Laura, or if we want to take questions now.
I think we leave questions toward the end, if that's okay. We're going to move on now to Dr. Adam Boyce, who is the program director for our one-year program in material science and engineering.
Thanks, Laura. I'm going to share my screen and share my slides that I have to introduce the subject. So my module, or my course even, is a one-year program, as you said, in material science and engineering. And that subject in particular is a specialization in learning how materials, as you see in the slide here, it's a multi-scale thing, okay? We build materials from the atomic scale, and we put those atoms together, we create a structure at the nanoscale. Then we look at, micron scale, hundreds of microns, etc., how those materials form together. And then we essentially build up the material to the point where it can be added into an aerospace component or whatever it may be in industry. And a lot of the research and teaching that goes on within this course operates and teaches you how to design and structure material at these various scales. So we have a lot of passionate staff who have experience in polymers, in metals, ceramics, etc., all with an underlying theme of sustainability as well. And the material subject is also about this triangle, which is a classic materials kind of thing of how do we process the material, and how does that lead to the structure of the material, and how does that lead to the output properties of the material that go out in the real world and perform in the aircraft or the cars or whatever it may be. So material science and engineering is a very broad subject, and you can explore a lot of different avenues within your interests. So I've given the course breakdown here a bit. Okay, so as you said, it's a one-year program. We have 90 credits. Okay, across 3 trimesters. 60 credits of our course is taught. Okay, and the modules we offer are split primarily. A large portion of the modules are in the School of Mechanical Materials Engineering, but we have modules in chemical engineering, electronic, biosystems, chemistry, and physics as well. Because materials is such a multidisciplinary subject, you get exposure to a lot of these different types of fields, okay? And I'll go through those modules in a moment, but the final aspect of your degree is in the summer trimester, where you do a research project, and you get paired with an academic who will, you'll either decide a project yourself in agreement with them, or they'll assign you a project, and you explore in great detail a particular new avenue of research. Okay, so the modules in question, we have core modules in material science and engineering, ceramics, polymer engineering, deeper materials related things like thermodynamics. You'll learn about research skills and advanced metals as well. Okay, again, you'll have your final project in the summer. And then these are the option modules. So the ones I've just listed are core modules. These ones are option modules where you can have things from a sustainability perspective, looking at energy systems, chemistry of materials and nanomaterials, characterization techniques, which is critical to material science, and so on and so forth. There is also a focus towards, what happens when you get a job in industry, and you can look at professional engineering, finance, and management for example. You can focus on biomaterials if you like. And just briefly, in terms of the breadth of kind of materials expertise in the school who contribute to the projects and your teaching, etc., you can look at polymers and composites, and we've a substantial amount of staff in that. Metals and 3D printing, biomaterials, ceramics and sustainable materials. And this is just an example, and there's cross-linking between all of these people as well. So there's a lot of support in you pursuing your interests in school. So that's the breakdown of my course, and I'm looking forward to discussing at the end in questions. Thank you.
Great. Thanks so much, Adam. Our next program director up is Dr. Mert Kelkum from our 2-year program in Material Science and Engineering.
Thanks, Laura. Hi, everyone. I'll just share my screen. Hi, everyone. Thanks for joining the webinar, and it's glad to be here presenting the ME in Material Science Engineering. The main difference between the 1-year program and the 2-year is additional year is mainly for the internship. There's a 6 to 8 month internship, and there's a longer thesis period. But I'll just go through the program, like I'm the program director, and our head of subject is Professor David Brown. So what is material science engineering? Is Adam pointed out very nicely, and in general, it's the understanding the structure property relationship of the materials, and it's one of the fields. It's present in one of the all the top institutions in the world, and it is to improve the performance of the engineering materials, either by modifying the structure through processing or chemical composition analysis. But like, it is a field that's crucial because it underpins every technological advancement, from developing stronger and lighter vehicles towards to creating biocompatible materials for medical implants. Ultimately, it's actually improving our quality of life and addressing the global challenges. Just to give some statistics, around 85% of our graduates are currently either in employment or pursuing further studies. And what roles our graduates are having it varies. So it ranges from the research development engineers to like materials engineers to manufacturing engineers, etc. So our program is developed to improve the skill set that our graduates can perform various tasks. So it is the only such course in the country with a dual accreditation. We have dual accreditation both from the Engineers Ireland and UK body, Institute of Materials, Minerals and Mining. And it is a 120 credit program. As stated, there is involved in a 6 to 8 month internship, which is around 25 credits. And there's a final year project as well. So how did we divide the content of the program? It ranges from the main material types, the metals, ceramics, polymers, composites, with specialized material types such as semiconductors and materials processing. Also, we give emphasis on the 4 main sectors, and then the energy, biomedical, manufacturing, and nanotechnology. As stated, the program involves 6 to 8 months industrial work placement. It's starting in the 2nd trimester of the 1st year. Here's a list of modules. I'm not going to get too much into detail, but basically it covers those main material types and specialized materials, along with the specialized subject areas, nanotechnology, biomedical, energy, and manufacturing. So where does our graduates, like actually students' work placement took place so far? Ireland is a well known for biomedical industry, but in addition to that, we got biomedical, like the aerospace, energy, and like electronics industry. So we got like the actual students are doing the internships, which allows them to get the work, increase their chance of securing a job in these industries. So these are some of the companies. There are some of them are multinational and well known, and are graduates currently placed in these companies. So it's just a few testimonials before I finish up, like what is actually emphasized from our graduates' perspective is varies. So some are mentioning about in more specific destructive and non-destructive testing of composite, for example, for one of our graduates working in the Lockheed Martin, California. And other ones are like emphasizing the interdisciplinary nature and a combination of the theoretical and practical experiences. And some is the broader, broad exposure to the different areas in industrial placement, and again, the industrial placement, interdisciplinary nature. So thank you so much. I will be happy to answer your questions after the webinar. Yeah, thanks.
Great, thanks so much, Mert. Our next program is our ME in Energy Systems, and we have Dr. Ali Sabari Mer.
Thank you. I'm just going to share my slides. Okay, can you see the slides, Laura?
Yeah, they're there now.
Perfect. Okay, so hello everyone, and thanks for being here today. I'm Dr. Ali Sabari Mer, Assistant Professor in Mechanical and Materials Engineering and Program Director for the BGUT offering of the ME Energy System Engineering. And the UCD base program is led by Associate Professor Dr. James O'Donnell. So before I go into the structure and the features of our program, I would like to start with a few highlights from recent news, examples that reflect the real-world relevance and urgency of what we teach here. So you have probably seen similar headlines about the grid stability, hydrogen as a future fuel, offshore wind development, and even the integration of renewable energies with digital technologies. So these are not distant concepts, and they are active areas of innovation and policy right now, both in Ireland and globally. And each of them ties directly into what energy systems engineers do. So this brings us to the question, why energy system engineering? Because the challenge we face from climate change and energy security to the transition away from fossil fuels requires system thinking, technical depth, and interdisciplinary collaboration, right? And this program is designed to equip you with exactly those skills. So now one of the key features of this program is that it's not limited to renewable energies and energy systems. We take a full systems perspective. So students explore not only wind and solar as an example of renewable energy systems, but also nuclear, fossil fuels, carbon capture and storage, and hydrogen. And the engineering, more importantly, the engineering principle behind extraction, processing, and combustion. So related to the structure of program, this 2-year program, 120, similar to the previous example that provided by our colleagues, ME program is designed for students with a strong background in engineering and technical science, typically mechanical, electrical, electronic, and or chemical engineering. So it builds on prior study and expand your perspective across multiple energy domains. And a key feature is that we are offering a 6 to 8 months industry placement after year 1. And it offers hands-on experience with leading energy companies from January to September. On this slide, this diagram shows the different pathways into the ME Energy System Engineering. If you're a UCD undergraduate, you will start the common entry in stage 1, then choose a stream like mechanical or electrical and electronic engineering in stage 2 and 3. And from there, you can progress directly into the 2-year ME program. And students from outside UCD can also join the program, either by entering the standard 2-year ME track, or in some cases through a 12 months route with 90 credits, if they have prior recognized learning, of course. And it should be noted that this shorter version, 90 credits, I mean, doesn't include the industry internship. So similar to other programs, we have core modules. Our core modules cover key topics such as energy system and climate change, engineering thermodynamics, and also energy in buildings. You will also complete a 20 credit research program, professional management module, and also 6 to 8 months, as I explained before, industry placement, which has 30 credits. And on top of that, you will choose 5 option modules, and it includes engineering thermodynamics 3 and other modules that can be seen here. Energy economics and policy, and also data science for engineering, which are very popular among students. So our students complete let's say, their internship in top employers such as ESP, Airgrade, Arup, and other well-known companies in Ireland and globally. And here, since 2010, we have had 280 graduates from the ME in Energy System program, with over 120 coming through UCD's 3+2 pathways. And numbers that can be seen have grown steadily, reflecting strong students' interest and industry demand. And finally, there are just a few examples of where our graduates have gone after completing the program. And we have people in cutting-edge roles in CEO levels, director levels, and senior engineers in different companies in Ireland and in global. So these profiles show the bridge of opportunities available for you to our graduates, not only in Ireland, but across global energy and technology sectors. So thank you so much, and I'm happy to answer any questions.
Great, thanks so much, Ali. Our next person up is Associate Professor Nikos Papakostas, who is going to cover our newest program, our MNGC in Robotics and Intelligent Manufacturing.
And thanks, Laura. So I'm very happy to be here with you. I'm the Program Director of the MNGC Robotics and Intelligent Manufacturing Program. Some information about this program: it's a 1-year full-time program, 90 credits overall, and requirements require an honors undergraduate degree, level 8, with a minimum upper second-class honors or international equivalence in engineering or science, meaning that we accept engineers from all different disciplines, software engineers as well as scientists. This is the first year that this program is running, and it's already one of the most popular, the second most popular program in our school, and the third most 1-year program in our college. And now the first question is, why should someone enroll in this program? Robotics and intelligent manufacturing technologies are very important for a number of different companies in different sectors, especially in Ireland. There is significant lack of skills of automation experts in Ireland. As a matter of fact, the salaries are among the best paid salaries in Ireland. There are a lot of Irish companies and system integrators who are struggling in recruiting engineers with robotics and automation, the required robotics and automation skills. And the goal of this program is to produce experts with sufficient scientific and practical skills in the areas of robotics and automation. I include that article that was published a few days ago that is based on a report that was prepared by Engineers Ireland. Ireland will need more than 22,000 more engineers in the next few years. So when it comes to learning, Most of our modules are lab or project based in the areas of robotics, automation and control, digital manufacturing, including different software and tools that can be used for designing products and process, including simulation models for manufacturing process, as well as data analytics and artificial intelligence. We have a summer project which is done in cooperation with Irish automation and manufacturing companies. And we have state-of-the-art lab equipment and software, including industrial robots, collaborative robots, vision systems, sensors and devices, as well as computer-aided systems and simulation tools. So some of the equipment that we have is state-of-the-art industrial robots, mobile collaborative robotic platforms, automation equipment, including PLCs, different types of collaborative robots and different end effectors, as well as software tools that engineers can use for designing the robotic and automation process, PLCs, advanced vision and lighting system. And you see here, for instance, an example of using 3 different vision systems and how we can detect the pose of human operators. We put a lot of emphasis on digital manufacturing tools. You see here, for instance, an example of how Pro simulation tool can be used for designing a process where 2 robots work together for assembling parts for an automotive company. Some more information about the modules. We have 8 core modules that you see here in red, starting with introduction to robotics and supply chain design and project management in the first trimester, to operations management, machine support systems, robotic applications, industrial automation in the second trimester. And we have, of course, a number of options ranging from control theory to core mechanical engineering or software engineering modules. And then at the end, we have the summer trimester. In the summer trimester, we have the Applied Robotics Research Project, which is typically carried out in cooperation with Irish research, robotic and system integration companies. And in my last slide, we include a testimonial from the CEO of Cook Ireland, Brian Cooney, who said that engineers and scientists with a strong background in robotics and automation are among the best paid jobs in Ireland. They're typically involved in large-scale projects, developing state-of-the-art solutions, and they typically progress to senior roles in a quite fast management or even management positions. And according to Mr. Brian Cooney, this master's offers all necessary skills to engineers and scientists to enjoy a really rewarding career in the area of automation and robotics. And that concludes my presentation. I would be very happy to answer any questions that you may have at the end.
Great. Thank you so much, Nikos. That's all the program kind of overviews that we have. Next up we have is a kind of student experience. So we have one of our current students, Lena, who's currently in our ME in mechanical engineering.
Hi everyone. So my name's Lena. I'm in my final stage now of the 2-year Masters in Mechanical Engineering program in UCD. So I did my undergraduate degree in UCD as well, so it was kind of a natural progression wanting to continue my studies. And I chose to do the mechanical engineering Masters because even though I liked aspects of the other areas, I wanted to keep it broad, and it kind of overlaps with a lot of the other programs, you know, like that we're looking at. So it's good. It's kind of I like that it's kind of broken up by the internship program and then the final year project in final year. So the first semester is more focused on modules and exams, and then you do your internship, and UCD was really good for this. It was actually, like, I think there were so many companies that came through UCD, so it was easier to get a placement, and you can decide kind of what area you want to try out. And it's really good because now graduating you have that experience then when applying for other jobs. And so I did my internship in sustainability services in a consulting firm, so that was really interesting. It's kind of something that's becoming more and more important, and so that was really interesting to try. And yeah, I have that experience now when I'm looking to do other things. So then in final year, then you do the project. So that's what I'm doing at the moment. And that's really good if you're interested in learning new software or doing things that aren't explored so much in the modules. So for example, I'm doing a lot of finite element analysis in my project, which is something that I wanted to try it. And then the teaching class experience is also really positive. The classes aren't too big. The mechanical engineering one, which is mine, is probably one of the bigger ones at maybe 50 people in my class. And it becomes, yeah, doing the project in final year, you kind of learn to do a lot more work independently then as well. And then next year after I graduate, I'm going to work in mechanical building services. So I'm using a lot of what I've learned, obviously in UCD, it's really relevant to what I'm going to do. So that's really positive. And yeah, I'm looking forward to that. Thank you.
Great, thanks so much. Really interesting to hear that you've had a good experience with your workplace as well, which is a big part of our 2-year programs. So we're going to move on now to our Q&A section. So as my colleague Katie has said in the chat, please type your questions in the Q&A button at the bottom of the screen. We've had a couple come in now. So we're going to go to that. If you just bear with me. So the first question up is Nikos, it's for you. It's just in relation to robotics manufacturing engineering. Is the applied robotics research project in that, do students have to look for the internship independently, or will it be provided through the companies in collaboration with UCD?
So how we typically do it is we contact a number of companies. They get back to us with a number of projects, and we assign those projects to the students. But the students are also free to get back to us suggesting their own project.
Great. Thanks, Nikos. It was stated that someone's asking, it was stated at the start of the webinar, I'm guessing, Vincent, through your various slides. They're looking for regarding the research aspect and the available research groups in themes relating to manufacturing and material science. And they're wanting to know what those kind of groups are, and do they have available vacancies for master's students to join the group, I suppose, whilst they're current students?
Yeah, I think, and some of my colleagues can jump in here, but when the students are working on their research projects, they would kind of be embedded in the research groups of those colleagues. So they'll be collaborating maybe with the PhD students, the postdocs, and the academic staff. So they wouldn't be working in isolation. They'd be working on their projects that those research groups are currently engaged in.
Okay, great. Thanks, Vincent. Ali, this is for you in relation to the ME Energy Systems Engineering. Do you have any examples of graduates who've worked in research after completing the program? And do you know offhand the proportion of international students that are enrolled in the program?
Okay, so most of the students prefer to find a job in the industry, but definitely we have some students who pursue PhD in energy field. I don't know the name exactly right now, but definitely we have some students who decided to continue their study in PhD levels or higher. And what about the last one, the proportion of
international students?
Yeah, related to this, I don't have the exact number again, but we have some percentage of students who are international. So
great. Thanks, Ali. Kevin, there's this question and for yourself for I'm guessing the 30 credit engineering project. Does that have to carry on from the current degree, or can it be something different? This person in particular studied mechanical engineering, but they're doing software engineering at McLaren at the moment and wanted to kind of carry on the software engineering part, I suppose, for the project.
Yeah, so we don't have a specific software engineering stream within it. What we have is civil, electronic, electrical, and mechanical. And as if you're coming in as an external applicant, you can basically select the modules from across those 4 streams. So within electronic, there would be some software related, particularly within electronic, there would be some software related modules. I didn't show the full list of modules because it's kind of huge across the 4 streams. But if you look at our electronics engineering masters, for example, you will see most of the most relevant modules that are available to choose.
Great, thanks, Kevin. For the MNGC Material Science and Engineering, again, is it possible to do more than the 2 of the autumn electives? Since there are more than there's 5 in the spring one, out of which 4 would I have to be chosen as under? Sorry, apologies.
Yeah.
Yeah.
Thanks for your question. I think it is possible to do more than the 2 autumn electives. Yeah, there's just a careful balance required so you don't overload yourself in work, and that's some, it is possible. Yes, you can do that, but yeah,
Thanks, Kevin. I think that apology, I kind of messed up ask you that, but I think you got the gist of it there. Nikos, the next question's for you, just related to robotics and intelligent manufacturing. How should we proceed with the hours of an optional course that interests us or overlaps with one of the mandatory courses? Or mandatory modules, I guess they're kind of asking.
So, well, that depends on the timetabling process. Typically, there is no clash between core and option modules, but if a student wants to take another module, we need to make sure that it doesn't clash with the core module. Core modules.
Yes, of course. Yeah. And then that person's also just asking in relation to students working in their field of study during their studies. Have you found that that students are also trying to juggle working as well as their studies?
It's a full-time program. There's not much time left for doing anything else. And the labs are also very demanding, and we have modules that require a lot of hours in a lab, so I don't think it is possible.
Yeah, thank you. And then for Adam and for Mert, in relation to material science and engineering, but both touch on the more production side of materials. Do either do either of them do the 1 year or the 2 year program do the more investigative side? I think they're looking at practical imagery. Not an engineer, apologies.
Yeah, I can go ahead with that. I guess there's a balance between, some of it is manufacturing related, but a lot of it is, we have alluded to polymers and composites as a research field that you can work in while you're here. And a lot of that would be investigating how materials behave under fracture loading that results in fracture, for example. So that is a definite possibility. In general, for example, my own research is on lithium-ion batteries, and I look at how structures influence the performance of lithium-ion batteries. There's a lot of investigative work on the structure of materials and how they perform, and the processes that lead to those improvements as well. So it's not all process related. There are investigative elements to all of our research, and I can let Mert elaborate on that if he wants as well.
Yeah, it's just
Thanks, Adam.
add on to the like with the ME projects, because it's a long project, and majority of the projects are based on a novel manufacturing technology, like additive manufactured components, where we investigate different mechanical performance improvements, and that's definitely part of it is the fractography that we investigate fracture surfaces, as well as a lot of materials characterization techniques involved to understand the mechanisms. Yeah.
Great, thank you both. Ali, it's just in relation to the energy systems for the work placement, the professional internship. Do students have to source their own internship, or do you have partner companies that you're working with, or how does that work for students who are going on the placement?
So as far as I know, there should be both sides. They can find themselves, but also we have partner companies that I explained during the presentation. We are working with ESP, Airgrid, and lots of companies, and they can get connected with them to take their internship there.
Okay, great. And Lena, obviously, because you're one of our current students and you would have done the placement before, do you want to maybe talk a little bit about your experience of applying and getting your internship?
Yeah, so loads of companies come to UCD, and then you basically have access to all of the jobs on offer, and then you apply like a normal job, and then they all get sent off on the same day, and then after that the companies then decide who they want to interview. And there are loads of opportunities. I think everyone was able to get an internship. But equally, if you wanted to get your own, lots of people did that too. And the approval process was quite straightforward, if you wanted to do that either.
Great, brilliant, thank you. There's someone here who's currently working as a research assistant. They joined there right after their bachelor's in UCD. They're interested in doing one of our master's programs. They haven't mentioned which particular one they're interested in, but joining for the September 2026. They're just wanting to know, do they have an upper edge in the application process for selection based on, I'm guessing, having that bit of extra experience? I don't know if anyone wanted to comment on that for their own particular programs.
I'll go for it. I think we look at your background, your grades, your interests, your the field of study that you've been in before. We look at everything in the round, so it's hard to say whether that definitely is fantastic that you're interested in research and you're working in that afterwards. But yeah, we look at the whole picture as well. So it's hard to say whether it gives you the upper edge, but it's certainly a contributing factor having such experience. So that it's a good thing.
Great, brilliant. Thanks, Adam. I suppose that's likely true for across all the programs. Kevin, this is for yourself, just engineering with business. What are the opportunities after having done the master's compared to maybe if you only had the undergrad, their background being specifically in electrical engineering?
Yeah, okay. So I suppose one of the big advantages, first of all, is the master's. As we said, it's accredited by Engineers Ireland for chartered engineer. That's not an immediate thing when you graduate, but a couple of years down the line, it's a big advantage. Secondly, I suppose the other big thing is that the fact that you're doing an internship during it, you will have actual work experience and you'll have direct contacts with a company, or at least, you'll have direct contacts with the company you work in, but also companies that you interact with through working with them as well. Those are probably the two big standout differences. Your research project as well will help. And then obviously, in addition to that, you have the additional technical and business expertise that are going to essentially strengthen your CV in a broader sense as well.
Brilliant. Thanks, Kevin. This person hasn't mentioned a particular program, but they're just asking, given the interdisciplinary nature of our programs, is it possible to have some modules from other programs or other areas? They've mentioned computers, mechanics, physics as the option modules, or do they have to be taken from within the program itself? If anyone wanted to jump in on that.
I'll take that, Laura. So as I said, a lot of the program structures already have modules from other schools and colleges in UCD, whether it's in physics, in chemistry, in business, in maths, computer science. So we try and build the program structures around those modules, and as a result, they're timetabled in so they don't clash. And as Nikos said earlier on, if somebody wants to identify another module that mightn't be on the core or option list, they're welcome to do that. But the only thing they have to be careful of is that it doesn't clash with one of their core modules in the timetable. So we wouldn't factor that into the timetabling process for somebody to go off on their own and find a module. We try and have enough breadth in the program structures to capture that kind of scenario and factor it into the timetable so that there's no clash.
Brilliant. That makes sense. That was all the open questions in the Q&A box, but there was one email to my colleague, and it's for Lena, yourself. So they were asking about the workload and how have you found the transition from undergraduate studies to master's studies, and how's that affected the workload?
It was probably a step up, I'd say, but it's kind of broken up a bit more. So having, first semester being modules and exams, that was quite intense, but then afterwards you go on internship and you're working full time for 8 months. So you kind of get a break from that. And then you come back to UCD and you're doing half the classes while doing your research project as well. So it's more kind of coordinating, managing that. So it is more broken up, even though it is a big workload, like it is full time, but it's yeah, it's not always just studying for exams, and it's kind of broken up a bit.
Great. One more question I think we have. Again, they're looking at a majority of the programs within this school. They're looking for a master's that would be more relevant if they're interested in working in the automotive sector. And they believe that there's no OEM for automotive in Ireland, but maybe there's potential scope in Europe, if anyone knows.
I would take that. I worked a lot with the automotive industry. So I would say that the robotics and intelligent manufacturing program would be the most suitable because the padding white, for instance, the chassis of a car is completely made using robots. And the car is also designed using computer-aided systems. So my answer is robotics and intelligent manufacturing.
Great. Thanks, Nikos. So that's really all the open questions that we have there. So thank you very much for everyone for joining us. We truly appreciate your time and engagement today. Thank you to all our speakers for your great insights. If you have any further questions after today, my colleague Katie will pop her email address and my email address in the chat. So grab that there. We're more than happy to engage with you on any questions you have at a later stage. If you need additional resources or if you're making an application to us as well, please don't hesitate to reach out to us. But thank you very much for tuning in and enjoy the rest of your day.
Thank you.
Thank you.
Thanks.
Bye.
Thank you.